Hello, and can everybody hear me okay? See okay? Everyone doing okay today? Brains almost melted? For the people in the back, there is going to be a live demonstration as part of this presentation. I've done the best I can to make things visible, but you might want to move forward because some things might be a little difficult to see. Welcome to building a global multi-tenant monitoring platform. I'm Jeff Moody with Datapipe. I am a cloud engineer at Datapipe. I was the principal engineer for architecting and building the Datapipe cloud monitoring platform product. And I do extensive work in cloud computing and the DevOps tool chains and DevOps systems. As a general disclaimer that I'm sure you've heard every single talk today, my opinions are my own, not necessarily representative of my employer. And your mileage with the cloud monitoring platform may vary, but I hope to be generic enough that this applies to everybody. So who is Datapipe? You may have seen us out on the show floor. We're a managed service provider headquartered in Jersey City, New Jersey. We are the premier AWS consulting partner. We provide single provider solution for all of your IT needs. We have offices and data centers in New Jersey, Virginia, Silicon Valley, Iceland, London, Hong Kong, Shanghai, and Singapore. So we have a lot of global presence. And we do fully and partially managed solutions on Linux, Unix, and Windows. We offer operating system management and support, application management and support, network, DBA, and security and compliance management and support. We do have PCI and HIPAA compliant offerings. So what do we bring to AWS? As most of you know, you can kind of run AWS on your own. You don't really need a data center provider for that. So why would you want to use an MSP like Datapipe? Well, we have a lot of competency with AWS. We've been running solutions for ourselves and our customers in AWS for a number of years. And we can act as an extension of your existing IT team or replace it if you really want to. But we prefer to work with companies that we're just kind of another part of the team. We provide single vendor billing and governance, cloud provisioning, infrastructure and application monitoring, which is what you're going to be hearing about here in a minute, database tuning, scaling, we do security, and as part of the tie-in for monitoring, we do issue response and resolution. We have a cloud reports utility, which if you're interested, you can come talk to us on the show floor, that provides cloud budgeting and a lot of insights into the health and state of your AWS configuration and setup. We have our own cloud management portal, which you'll be seeing in a little bit. And we have a service that we call committed instances, which provides you the cost benefits of a reserve instance without the upfront spend. We take that hit for you and give you a better month-to-month price than you would get with just your regular on-demand instances. We also have Direct Connect in most of our data centers. So if you need IT solutions where you have Direct Connect from a physical solution into AWS, we can provide that for you in New Jersey, Virginia, Silicon Valley, London, and Singapore. So if you want to do things like running Oracle RAC and connecting your EC2 compute into that, we can definitely help you do that. So Cloud Reports is a product formerly known as Nuvem. We acquired them last year, and it provides optimization and forecasting for your AWS environment. So on to the meat of the presentation. The problem that we ran into in late 2001 with Datapipe and our cloud offerings is we had a growing number of customers using AWS for their different solutions, and we didn't really have a system that could fit the needs that a cloud system requires. We had a traditional agent-based monitoring solution that was based loosely on Nagios, and we were having a lot of scalability and configuration issues when dealing with customers that were using EC2 like you're supposed to and spinning up and shutting down instances all the time. That was generating a lot of false positives, was generating a lot of confusion and a lot of frustration. Additionally, a lot of the configuration of the agent that we had built for our legacy monitoring system was built to work inside our data centers. It required a lot of open ports, a lot of kind of loose security, and that just doesn't work very well in a cloud. You kind of want things to be locked down. So we had a couple of different ways that we could look at addressing this issue. The first is we could try and fix the legacy monitoring system, which we weren't interested in doing because as a company we were getting rid of the legacy system and moving to a new system. Well, that new system was SNMP based, well, is SNMP based. And I don't know about any of your opinions, but I trust SNMP about as far as I can throw it, which isn't very far because it is intangible and it's something nobody manages properly. So not feeling like SNMP was the best choice for our cloud solution, we had two real options. One would be to build something on our own, which would introduce a lot of its own challenges because that would be a really substantial development effort where we'd have to build all of these systems. And then it would provide us a support and maintenance nightmare because when you roll it yourself, you only have yourself to blame if something breaks. And as this is something we were looking to provide to all of our customers, we wanted as reliable and robust of a system as we could find. So the last of our options was to build a new platform from a different vendor that wasn't using SNMP for all of their monitoring. So the biggest challenges we had in trying to find this vendor-provided solution is we needed multi-tenancy. We have several hundred customers, thousands now probably, and we wanted to provide a central monitoring solution that could support all of our customers at once without us having to produce a monitoring solution for each and every single customer. We also had a question of whether or not we could deal with an agent-based solution, and decided that we wanted to go agentless because in our legacy system, just about any time anything went wrong in a customer's system, the first finger that was pointed to the agent because this is code that the customer didn't know. It was code that they didn't run. And so when something goes wrong, you point the finger at the thing you don't understand. So being an agentless solution removed that as a pain point for us to manage and maintain. It removed a finger pointing situation, and so it was just kind of one of our core requirements. We also wanted centralized management, but we also wanted to be able to easily set up collectors inside each local AWS region or VPC network to keep latency and network utilization to a minimum when running all of these monitoring checks. So as some of you may know, if you say monitoring and you say agentless, you mean Xenos. So we built our cloud monitoring platform around Xenos Service Dynamics. We did engage them for a substantial number of customizations to fit into our environment and fit our needs. Xenos, as I said, is an agentless solution. For your Linux instances, it's using SSH. For Windows, it's using WMI to be able to query and monitor everything inside the system. We found it to be tremendously scalable, and we found it to be very easy to support because it's a pretty well-established monitoring platform. So our deployment architecture, you can see we have a master, which lives inside our data center in New Jersey. We have a DR copy of this master in Hong Kong in case of catastrophic failure. And then we have collectors in each AWS region, and we have collectors inside of any customer's VPC. And those collectors then reach out and communicate with the customer servers to collect the monitoring data, pass that back into the master where the data is examined and alerts are generated. So we had a couple of different deployment challenges when we started using Xenos. As some of you may be familiar with, and some people that I've spoken to on the show floor have said, the AWS XenPack has a lot of good features, but it has a number of limitations, especially at the time that we were building this in 2011 and 2012. The AWS XenPack required one SSH key per account for instance auto discovery, and that just didn't really fly because a lot of our customers were using multiple SSH keys for whatever the server's purpose or function would be. We also had a number of concerns in that to run kind of as it comes out of the box, we would have to copy all of our customers' SSH keys to any and all of our collectors so that if they decided to spin up instances in US East where they had been running in US West, we would have the necessary information to start monitoring their systems as fast as possible, which gave us a bit of, well, a lot of concerns because that then meant all of our customers' keys were located in all of our collectors around the globe, and that's not a good idea. We also had a number of issues initially exploring the Xenos APIs. The programmability of their platform is very good. It just was not tremendously well documented. So what we ended up deciding to do, and our development team did an excellent job of providing, is we have a single click set up through our dashboard. And with the click of a single button, your instance gets enrolled into the Datapipe cloud monitoring system. We will update the security group rules for that instance to be able to allow ingress traffic from the collector. We use custom code to copy the keys to that collector. That custom code also does regular maintenance on our SSH key chain to make sure that only keys that are supposed to be there are there and keys that aren't. So if you were running instances in US West and stopped, your keys will be deleted from that collector so that in the off chance something were to be compromised, your keys won't be. We also ensure presence of that server when you click the button in our inventory system so that when alerts are generated, tickets can be created in our ticketing system and we can take action. So that synchronization of information between the monitoring system, the inventory, and ticketing system is kind of core to our cloud portal. And we also provided you destroy your instances through our portal, ensure that all of the monitoring data is removed from the monitoring system when it's deleted, and we'll make sure that no false positives are generated so you don't get called at 3 in the morning because your server is down because you deleted it. We also are able to leverage this cloud monitoring platform for our hybrid data solutions. Like I was saying, if you had the need to run, say, Oracle RAC and connect that into your EC2 compute, we can provide that because we have collectors in all of our data centers already. So we can provide a single tool and kind of a single pane of glass to provide visibility into monitoring for your full solution. We decided to build our own interface because I don't know how many of you have used Xenos, but their interface can be very confusing. We also had a number of issues with the ACLs for their monitoring system. They basically provide you view-only or essentially root-level access. There really is not a whole lot of granularity as to what their user accounts can provide. And so by abstracting this into our portal, we can provide better granularity and better ACLs through our system that is then in turn making API calls to Xenos. So at the end of the day, why would you want to use cloud monitoring with Datapipe? And the long and short is, if you're using us as a managed service provider, you're using us as an extension of your team to be able to provide issue response and resolution. And we have what we call a SEAP, or Solution Escalation Action Plan, which is kind of a run book for how you want us to resolve your issues. That can be as simple as, yeah, give me a call at 3 in the morning when something breaks. Or it can be as extensive as restart this process, delete old log files, do whatever you need to do to fix my application and bring it back up. Well, without being able to monitor those systems and alert our global response center to know that there's a problem with your instance, we can't really respond to a problem we don't know about. And so that's really kind of where the cloud monitoring platform comes in. We do have SLAs in place so that we can make sure that we can respond to those incidents as quickly or as slowly as you want. And we also can help provide visibility into the health of your environment to help calm you down. So as a platform, we provide process monitoring. We do auto discovery using Xenos's auto discovery process. Can discover all sorts of different applications. We can provide URL monitoring and your basic system monitoring, rather than just your basic CloudWatch network in-out CPU statistics. We can provide, hey, is Nginx running? So I've talked a lot faster than I thought I would, and I apologize for that. But now we're going to get on to the demo. And give me a moment. And can everybody see this okay? Everybody see this okay? In the back, you're good? So this is the Datapipe Cloud Dashboard for AWS. And as you can see, we have instances running here in Northern Virginia, and we have in Northern California. And a couple weeks ago, I had set up this instance, 9 days ago to be exact, and enrolled it in our advanced monitoring. So as you can see, here you have your visibility into your file systems. And you can see earlier this morning I generated some data so that this wasn't just a boring straight line. We also can cover inode utilization. You can see here are processes which have been auto-discovered, and I can see the performance and memory utilization of those processes. And for HTTP content checks, we can show response time and size. So this is all good, as I said before, relevant information to help you understand what's going on in your system. Here's where you can configure the different alerts that will trigger tickets in our ticketing system and trigger responses from our global response center. These are our same defaults of CPU being overutilized, memory running out, and file system being filled. These are all amazingly user configurable in the most clean and semantic way possible of Python. And as you can see, we probably have a little bit of polishing to do, which is why this is still flagged as a beta product, but we can update our thresholds on demand. We have our system level graphs for things like load average, CPU utilization, memory swap, and I/O. And you can see the different history of events, if any events have occurred, which gives you an audit log of what's gone on with your instance. So to show you this enrollment process, I spun up another instance this morning here in California. And as you can see, don't have advanced monitoring enabled, but I do have this enable button. And to walk through the process, here we have our credentials. So I actually need to grab my key. And security key pairs. We do provide, oh, I could have sworn I saved that. So, because I did not save the key pair, because we do provide a online store for your SSH keys, so that way we can automatically enroll this, but as you see, I didn't have that key saved, so without having access into the server, it's hard for me to be able to set up monitoring for it using SSH. But let us just make another quick instance here. Yes, I want to create the instance. And here we can save the private key. These keys are stored in an encrypted data store in our system, but we've found a lot of customers really like using us as this key store, so that way they don't have to necessarily maintain the inventory and as much diligence around keeping their keys. And we will call this live demo. And reviewing everything, we start the instance. And here in just a few moments, I should have a new server. So while that's starting up, we do have two microphones here in the middle. Do we have any questions? Anyone? Bueller? Well, here we have a now running server. Yes, sir. Can you move to the microphone so that everyone can hear you, please, if you don't mind?
In your features there, do you have a way to aggregate all of your data instant globally at cost so you can see all of the performance like CPU or things like that?
That's an excellent question. At this point, no, we don't have that aggregate view, but it is something that we're looking at building to provide an aggregation of all of your servers to give you a true single pane of glass rather than multiple panes.
And also related to that topic,
Yeah.
are those data can also be available to the customer in the form of maybe tag delimited file or something like that, so that we can, manipulate that data, machine it, or we send it to some data warehouse?
At this point, I don't believe we're doing any sort of file monitoring of that sort, but there's no reason why we couldn't write code to provide that for you. That should be relatively trivial. So now that we're here with a running instance, we can run through the enrollment process. And now I know I have this key. And here, as I said, you can select which security group we're adding and updating rules for to allow ingress from the monitoring collector. And we have the current terms and conditions of monitoring showing that we are connecting via SSH or WMI to perform all this monitoring. And we are enrolling. And if you go into the security groups for the instance, you can see where we've opened ICMP and SSH access from our monitoring collectors in the appropriate region. And after a few minutes, there has to be some initial auto-discovery processes that are run, and then data will show up. So I have gone a lot faster than I hoped to, but that means all of you get more time to kind of relax here at the end of the day, unless anyone has any more questions. Yes, sir.
I'm even going to walk up to the microphone. Can you give an idea, if you've deployed this already, how, for a given collector, how many machines it's monitoring, what time granularity, what time sampler you're using for that monitoring, given it's agentless, and how big of an instance does that collector have to run on?
For most scenarios and most of our VPC deployments, we're using an M1 medium instance that can monitor upwards of 1,000 instances using a 5-minute granularity. All of the information is actually stored in RRD files, which is relatively data dense, and so it doesn't require a whole lot of CPU and disk capacity. So yeah, we've been able to monitor roughly about 1,000 instances with an M1 medium without a whole lot of issue. If we need to scale things up, we can scale things up, but that's been our average. Thank you. Any other questions? Thank you very much.